Hello, good afternoon, everyone. We meet again. Thank you for watching. So today I'm continuing my lesson on chapter 12. Okay, those of you who are probably following are those who are in Form 5 now. For Form 4, probably you will not know much about it yet, but it's always good to have a head start. Okay, it's no harm learning anytime. I know your teachers have not come to chapter 12. You're just starting your syllabus, but it's okay. I'm just trying to complete the syllabus for my Form 2 students, Form 5 students. So I'm just actually trying to, do the video by request from a few students who have been searching for information on chapter 12. Okay, all right, so let me share screen. So I do not know who is with me here. So if you'd like to let me know, just type a note on the comments and I can see who you are. Okay, but anyway, I don't see many people here, but it's all right. Let me just present my class. Okay, presenting my, I think, I hope you can see this. All right, so this is the chapter 12, Coordination and Response in Humans, chapter Form 4. And up to today, I'm going to do 12.4, which is voluntary and involuntary actions. Okay, which is a simple one because you have learned this in Form 3 before. Okay, you have learned this in Form 3. Chapter 1 of Form 3. When you learn about the human nervous system, the spinal cord and all this. So voluntary and involuntary actions are very simple only. Okay, so just revise a little bit, just add a little bit of information. Okay, now what are voluntary and involuntary actions? Okay, so in BM we call it tindakan terkawal and tindakan luar kawal. Okay, voluntary actions are very simple, right? All the actions in our body are either divided to voluntary or involuntary actions. Okay, all the actions in our body. So what are voluntary actions? So these are the actions which we conduct, which we carry out using the skeletal muscles. Okay, so example, right? These are the things that we do that we are in control of. We know that it's happening, we're doing it. We can also control whether we want to do it or not. For example, jumping, right? Taking a selfie. And then this person, this girl is eating, right? Holding the chopsticks, bringing the bowl up to your, near to your mouth and then to eat the rice. So all this involves skeletal muscles, meaning the muscles that are in your arms and your legs. All these are skeletal muscles, okay? So the other type are known as involuntary action. When you have the in front there, it means the opposite. That means it is not voluntary. These are things that you carry out, that you will also carry out in your body, but you cannot control whether you want to carry out or not. Let me switch on my phone because I'm scared that I will get a phone call and I'll disrupt my lesson. Okay, so sorry. Okay, so you do not control it. You also do not know sometimes when it's happening. So this involves skeletal muscles as well, and also smooth muscles. Okay, now example, like for example, I'm sure many of you have experienced this before. You have touched something hot, okay, accidentally touched a pot on the stove, and immediately your hand will be withdrawn. You will pull your hand back. Okay, this is skeletal muscle. The muscles in your arms, in your hands, these are skeletal muscles. And the other one is, you see this? This is your esophagus, okay? When you swallow food, the esophagus, the smooth muscles along the esophagus, they will contract and they will relax rhythmically to produce what we call peristaltic action or peristalsis, to push the food down your throat, or down the esophagus, to deliver it into the stomach, and also all along the way until it reaches the anus. Okay, and that will not be food lah, that will be feces lah, right, at the end there. Okay, so these are the two types of actions that our body carries out. Okay, and it's some are with your control and some are without your control. Okay, now let's compare. Okay, so this will be a popular question. Compare and contrast between voluntary action and involuntary action. All right, okay, so this I've taken straight from the textbook. So it's very simple, nothing much here. You compare in terms of similarity first. Okay, both actions will involve stimulation. There must be stimulation before you have an action or before you have a reaction. Okay, there must be stimulus. You will not be doing things out of the blue. There must be something that happened first to make you carry out this action. Okay, and there's of course impulse. impulse running through the nerve cells called neuron. And also there will be an effector organ, the organ which carry out the action, okay, whether it's voluntary or involuntary. So both actions will have all these components. Okay, differences. Differences we can compare in terms of, number one, whether we do it with our own will. Okay, for voluntary actions, we want to do it, we can control it, and we know. Conscious of means we know it's happening. Okay, we talk, we walk, we pick up something, that one we know. Okay, the other one, the opposite, the directly opposite, it will be the actions that will occur automatically. Okay, and we do not even have to think about it. In fact, it's not within our conscious control. You don't even, sometimes you don't even know what's happening. You pull your hand back when you feel something hot, right? You don't even need to command your muscles to contract. Your brain will be sending the impulse automatically to your effector organ, and the contraction will be there. You don't need to directly be conscious to tell your hand to pull back your hand. Okay, so this is without conscious, knowing that it happens. Okay, for example, another thing is the peristalsis, your heart beating, it carries out 24 hours a day without you having to give control. Okay, without having to give instructions. Okay, the other one is involving what component of the nervous system. So we have learned in the previous lesson, all right, if you've forgotten, you just go and see the other videos in my channel. So we have talked about the somatic nervous system, which controls the voluntary actions in the body. Okay, the somatic nervous system. And then the other one for involuntary action, it is under the control of the autonomic, we call it autonomous nervous system. Autonomic or autonomous nervous system. Okay, so that one controls the involuntary action. Okay, next one, where we can compare. Okay, which center? Where is the center? Which is the part of the brain or part of your CNS, your central nervous system, that controls all these voluntary action? Okay, so the center for the voluntary action is in the cerebral cortex. That means the big part of the brain. Remember the one part of the brain there, the big part here that looks like, highly folded, that is a cerebrum. So that is called cerebral cortex. Actually, it means by cerebrum. You can just say controlled by the cerebrum. It's the same meaning. Okay. And then for involuntary action, they're controlled by two parts of your central nervous system. One is the medulla oblongata, which I've mentioned in my previous lesson also. It is that part, is actually the beginning of your spinal cord. It's at the base of the brain there, the hind stem, okay, the hind brain. And then the other one is hypothalamus, okay, also controls, receives impulse from your parts of your body, and it sends impulse to the other parts to produce the involuntary actions. Okay, and one more. All right, what type of muscle is involved? For voluntary action, it's always the skeletal muscles, the muscles that are in your limbs, your hands, your arms, your legs, your foot. Okay, and on your stomach and all that. You mean these skeletal muscles that is you can control the action of. Okay, you can control whether you want it to contract or you want to relax. Okay, to pull parts of your body. And for the other one, which is involuntary action, it involves the reaction of the smooth muscle. Smooth muscles are another group of muscles. Remember, there are three: cardiac muscles, smooth muscle, and skeletal muscles. So smooth muscles and also cardiac muscles, they are also under the involuntary action. Okay, you cannot, like for example, you cannot control your heart to stop beating. Okay, it's not within your control. It's an involuntary action, the contraction of your heart. And the glands which produces enzymes, glands which secretes hormone, that is also not within your control. Okay, so clear? So these are the things that you can write about when you want to compare between voluntary and involuntary actions. Okay, let's carry on. Now, let's go straight to the voluntary actions, a little bit more information involving skeletal muscles. So these are conscious actions. Examples: walking, talking, brushing your teeth, okay, holding your toothbrush, raising your hand to answer questions, okay, because you can control, of course. If I know the answer, I'm going to answer my teacher. I put up my hand and to show that I know the answer, all right? So it involves skeletal muscles. So these are the skeletal muscles. You see all these muscles that are covering your bones, right? We have internal skeleton, we call the endoskeleton. So the muscles are the ones that actually contract and relax to pull the bones for all these movements. Okay, and they are controlled by the cerebral cortex. Like I mentioned, the cerebral cortex is the cerebrum. So this is the center where all the impulse comes in, all right, and the integrating center is there to produce the correct response. So the brain will send out information from there, from the cerebral cortex to the effectors. Okay, let's look at the pathway. Okay, so when you talk about all these impulse and so on, you need to explain the pathway. Jalan. Pathway means the jalan, the route that is taken. Okay, so for example, a teacher asks the student questions. Okay, the stimulus is the teacher asking the question. So the question is the stimulus. Okay, the student hears it. Here's the stimulus. The stimulus is the question. And then the student knows the answer. All right. So this impulse, this stimulus will, of course, trigger, all right, the receptor. The receptor is your ear, all right, when your receptor receives the sound. So the stimulus will trigger the receptor to produce the impulse, and the impulse will be transmitted to the brain, okay, to the cerebrum. Okay, so you can see this picture here, cerebrum. Let me just circle here. So this is the cerebrum, and you see the impulse goes in, okay? And this neuron that brings in is called the sensory neuron. The sensory neuron is the neuron that brings in the impulse from the receptor to the integration center or integrating center, either the brain or the spinal cord. In this sense, is the brain. The brain, because this is a voluntary thing, you need to understand the question, all right? And then after that, you need to produce your voluntary action of putting up your hand. Okay, then you will see, right, the cerebrum interprets the nerve impulse to be sent to the effector. So now the cerebrum receives the impulse, it will produce the impulse and send to the effector. So before that, you will see there's another neuron in between. This is called the relay neuron. The relay neuron is all of it found in the brain or the spinal cord. Okay, so that is the relay neuron. And then this impulse will be sent out to the effector, okay, to your arm to contract the muscle so they can raise your arm. So this is brought by the motor neuron. The motor neuron carries the impulse out of the brain to the effector. So the effector will be your arm, right? Of course, if you want to answer question, you raise your arm. So your arm, your muscles in your arm is the effector, right? The muscles in the skeletal muscles. And then when your muscles receive the impulse, it will contract. It will contract and your arm is raised. Okay, the pupil raises his hand or her hand to answer the question, and that is the response. Okay, so you see in any of our explanation about the action, whatever action, whether it's voluntary or involuntary, it always starts with stimulus and then received by the receptor. Receptor will produce the impulse. Impulse carried by the sensory neuron. Then it enters the integrating center, and the integrating center will bring the impulse out, okay, through the motor neuron to the effector. The effector will produce the impulse. Produce a response, and then you have a response. Okay, so this is for voluntary action. Afterwards, I'll show you another example for involuntary action. Okay, next one. Yeah, it's raining now. I hope my internet is stable. All right, I hope so. Okay, now let's look at involuntary action involving skeletal muscles. So the example of involuntary actions that involve skeletal muscles will be the one your hand being pulled back when you touch something hot or when you touch something painful. Okay, so this is a special type of action which we call as reflex action. Reflex action is a special type because they happen fast and it's more for protection and it does not need to be learned. Everybody is born with reflex, even a baby, right? And when you're born as a baby, you already have the reflex. The doctor will have tested you, okay? Will have tested you with various tests to check that this baby is normal. One of the things they look for is the reflex action, okay? They will run the finger through the palm or the sole of the feet, and the baby's feet will sort of wriggle, right? They will move. And then there are some other reflexes, right? Okay, so I will not go into that into detail. So reflex action definition is an immediate response to stimuli. Okay, see the keyword immediate, quick, fast, without being controlled by the brain. You do not need to think, Your brain does not need to think whether I need to do it or I don't need to do it. It is automatically the response will come out, okay, will be given. So this is controlled by either two places. Either one is the medulla oblongata, the other one is the spinal cord. So it depends on what type of action it is. If you are touching something hot or something sharp, okay, that will be the impulse will go into the spinal cord. Okay. For the medulla oblongata is for things like when you smell pepper, let's say, all right, you smell pepper and then the pepper goes into your nose and then you feel you will sneeze, right? That is the response. That kind of reaction is controlled by your sneezing. Sneezing reaction is controlled by the medulla oblongata. And also blinking, sneezing, that one is medulla oblongata because it involves the organs in the face. Okay, so the pathway, the jalan, right? So you can see this person's finger is pricked by a needle and the impulse goes in, all right? And it goes in, of course, through the sensory neuron, through the dorsal root, goes into the gray matter of the spinal cord. After that, it comes out here through the neuron, the motor neuron, through the ventral root. This pathway is known as the reflex arc, not arch. It's pronounced as arc, A-R, like a K sound, reflex arc. Okay, so that jalan, right? Going in and then coming out, that entire route is known as the reflex arc, which everybody has built in, okay? Automatic we have. All right, okay, so there's no question yet, so let me carry on now. So let's look at the function of reflex action. It functions to provide protection. Okay, it makes a lot of sense. When you touch something hot, you do not want to burn your finger. Your small cells will die on your fingers if you keep on touching it. All right, it gives immediate and spontaneous response. Okay, it needs to be fast because you do not want to burn or kill so much of the cells. Okay, and of course it's to avoid danger, avoid some more injury. If your finger is pricked, you will move your finger immediately without much thought. You do not need to think about it. So this is an example, right? Touching something, you just immediately, accidentally, you put your finger into the fire. All right. Now, for tap or reflex action, there are two types. Okay, there are two types. Yeah. First one is three-neuron reflex arc. The one that we saw just now, you saw there were three neurons actually. There was this sensory neuron that brings it inside. Then there's a relay neuron in the gray matter. And another one that comes out, that is the motor neuron. That one has got three neurons. That is the three-neuron reflex action. Okay. The other type is called a two-neuron reflex action. Okay, so I'm going to give an example of this, right? So let's look at the three-neuron first. Three-neuron reflex arc. Okay, the two-neuron is this one. The three-neuron is this one. When your finger is you touch something hot and touch something sharp, that is involving the three-neuron reflex arc. The other one, two-neuron, is for your knee jerk. Okay, sometimes the doctor, they will test your reflex action by knocking just below the kneecap, and as a response, your knee will, your leg will kick up. Okay, that is normal. If it doesn't happen, then you are abnormal. Okay, everybody should have that response. Okay, now let's look at the three-neuron reflex arc. So this same picture here. See, the reflex action of moving the finger from sharp pin involves three neurons, and the communication between the neurons in the peripheral nervous system and the spinal cord. Peripheral nervous system is this one, right? Or this is going in, and this is the peripheral nervous system, and the spinal cord, that is the spinal cord, right? So that one is the three-neuron. Okay, why three-neuron? Because you see there's a sensory neuron, there is a relay neuron, and you can see another one. Okay, see the purple one going inside, right? Purple one bringing the impulse in. The green one is the relay neuron, and the blue one bringing the impulse out. That is another neuron. So there are three neurons here. All right. So this is the three-neuron reflex arc. Okay. Now the how to explain? So this is one of the questions that they may ask. Explain the entire pathway lah. All right. Explain how this person are able to move his finger after accidentally touching something hot, whatever. Okay, the question. So you need to know how to explain this. Okay, now look at it properly. What to say? You start with the stimulus. Okay, so the stimulus is pricked by the pin or the needle, right? When the finger is pricked by the pin, sensory receptor, that means the receptor that is inside the skin, right? This is the receptor here. This one, the receptor there, the special cells there, will detect the stimulus. The stimulus is your pinna, and it will trigger a nerve impulse. So it will start, the receptor will start the impulse. Okay, so sensory receptor is stimulated. Okay, next. All right, so this nerve response, this impulse is going to be transmitted, dipindahkan, transmitted along this green color thing here. This is the sensory neuron. This is a special nerve cell that's going to transfer the impulse into the spinal cord. Okay, so it's transmitted along the sensory neuron to the spinal cord. Okay, so you can see here the sensory neuron, number 2. Okay, talk about it in sequence. The next one is number 3. What happens in the spinal cord? Right now, the impulse is already reaching the spinal cord. The nerve impulse is transferred from the sensory to the relay neuron. So there's another neuron here. You see the relay neuron. The impulse now reaches the relay neuron. Okay, now next, number 4. After that, from the relay neuron, the nerve impulse is transferred to the motor neuron. So the impulse comes out. Okay, so this one is transferred to the next one. Okay, this is the motor neuron, number 4. Then afterwards, the motor neuron will carry the impulse to the effector. Okay, motor neuron transfers the impulse from the spinal cord to the effector, which is the muscle. And in this case, it's the muscle, your muscle in your arm. And as a result, the finger is moved. All right, so here's the effector. And lastly, of course, you have the finger, the response is moving your finger. So you can see going in, right? One arrow showing going in. Then this impulse will cross over to the relay neuron. After that, it comes out over here. That is a motor neuron. Okay, so you should be able to explain the entire sequence. Okay, as long as the meaning is clear, you don't need to use the exact words, but the entire sequence you must be able to explain. Okay, from the stimulus until you get the response. Okay, clear? Right, let's go on. Now, what about the two-neuron reflex arc? Okay, so this is only one example, which is the knee-jerk reflex. Knee-jerk reflex, two-neuron reflex arc. It only has got two neurons. Okay, what is the missing one? Which is the missing one? Okay, so you see an example for a two-neuron reflex arc is the one that is in this reaction called knee-jerk reflex, or we call it patellar reflex. You knock a particular tendon at below the kneecap. Okay, impulse will be produced and it goes to the spinal cord. The center is still the spinal cord, and then the impulse comes out, and your leg will kick upwards. It will jerk. So that's called the knee jerk reflex. Okay, so you can see this picture here. You knock at a specific place below the kneecap, which is called the patella. The patella is a kneecap. There's a bone there. All right. If you knock it correctly, your leg should kick up. So this involves only two neurons, so there is no relay neuron. There is only sensory neuron and motor neuron for this action. Okay, so the doctor sometimes will test your effectiveness of your nervous system by tapping below the knee. The kneecap actually, the kneecap using a rubber hammer. So you have your knee kicking up. Okay, you must leave your leg hanging. Let it freely, able to move freely. Okay, next one. So how to explain this? You also need to know how to explain this knee jerk reaction. Okay, again, the same thing, 1, 2, 3, 4, this one until 4 only. Okay, first of all, we start with the stimulus, number 1. When the tendon below the kneecap is knocked, so you're knocking at the tendon. The tendon is the tissue that connects the muscle to the bone. Okay, what bone I'm referring to is the patella. That is the bone there, the kneecap bone. So when it's knocked, the quadricep is the muscle in your, here, this is what they call your thigh muscle. Okay, your quadriceps, it will stimulate the stretch receptor. So there's a stretch receptor there. Okay, stretch receptor there. it will get the stimulus of the knocking, it will produce impulse. Okay, and the impulse is now moved along the sensory neuron. Okay, see number 2 there. Sensory neuron will transmit the nerve impulse to the motor neuron. Okay, you see there's no relay neuron. It goes directly into the spinal cord and it synapses this sensory neuron will synapse with the motor neuron. Okay, so this sensory neuron, it synapses with the motor neuron actually. So you can see here the synapse is here. Okay, inside the spinal cord in the gray matter. So number 3, the motor neuron then transmits the impulse from the spinal cord to the effector. Okay, the effector is the leg muscles here. Okay, which is your biceps femoris muscle. Okay, your quadricep muscles as well. Okay, so one will contract, one will relax. Okay, and that will cause your leg to jerk upwards. Okay, motor neuron. Then lastly, you talk about the response. When the quadricep muscles will contract, okay, and then it causes the leg to jerk forwards. So that is the response. Your leg jerking forward is the response. Okay, so this one is 1, 2, 3, 4 because it doesn't have the relay neuron. Okay, it's less one step. All right, so you should be able to explain this if the question requires you to explain the entire pathway of this two-neuron reflex arc. Example is the knee jerk reflex. Okay, clear, right? Let's go on. What is the importance of reflex action? Why do we need the reflex action? Okay, you should with my guess now, right? You immediately you got to pull your finger back because you want to avoid injury, further injury. So it is reflex actions, they function to produce spontaneous and immediate responses without waiting for the instructions from the brain. Because if you need to wait for instructions from the brain, it will be a split-second delay. It will be slower. Okay, because your brain need to process information and think, oh, this is hot, so I better remove my hand. So imagine all these milliseconds that lapse, that is going to happen, right? That is going to be delayed. There will be delay in your response. So imagine you prick your finger against something sharp, all right? So the additional time, you have to think about it, there will be additional time, okay? The additional time that is needed by the brain to analyze information, okay, to think about it, and then before triggering a response, right, may lead to serious injury. So there will be more injury because the fire will be burning more, killing more cells and so on. So here, imagine you have to think, I need to move my finger, right? That will give you a split-second delay there. So that will be more injurious, okay? It will injure more the finger. So since reflex action involves the spinal cord only without you thinking, so your brain can focus on higher level thinking. Don't have to think about all these things that no need to require thinking. So let the spinal cord carry out the response of protecting yourself. Okay, let your brain process more difficult things like calculation, right? Things that require thinking. Let your brain handle that. So all these things you do not need all this thinking. Let your spinal cord handle that. Okay, so next one. So we are coming to the 12.5. Okay, I'm going to cover 12.5 as well. The health issues that are related to the human nervous system. So there are a few issues, right? It may come out in the objective. It can come out in the structure as well. So you need to know about that. Okay, let's look at, first of all, multiple sclerosis. Okay, multiple sclerosis. All right, let's look at this. It is a progressive disease caused by abnormality. That means something is not normal in the immune system. So something is happening in your immune system. Your immune system is attacking the myelin sheath. Remember what's the myelin sheath? The myelin sheath is that fat. Remember that fat, the layer of fat that insulates your nerve fiber. Okay, insulation and also protection. So the one on the top is normal. You can see healthy, structure of the myelin sheath. So this is healthy. And then you see some people who have multiple sclerosis. You find that this myelin sheath is a bit damaged. So you have damaged myelin sheath, and that causes the nerve fibers to be exposed, some part of it. So this prevents transmission of impulse from and to the brain. So it will slow down the transmission. It may not even have transmission, effective transmission. So this person will have unable to carry out certain responses. Okay, so that is multiple sclerosis. Okay, next one, Alzheimer's disease. I'm sure you've heard of it. This is like a lot of old people who become like, they regress back to become little babies, right? Because they are unable to do a lot of the normal daily habits like walking, talking, eating, reading. They can't even do the simplest thing. They can't even sometimes, they can't even dress themselves. They can't look after themselves because they have a degeneration of the nerves in the brain. So if you look here, the one on the left is a healthy brain. The one on the right, this person suffers severe Alzheimer's. You will see that the size of the tissue, the brain tissue here, that means the neurons here, they are small. I mean, the size of the brain is smaller. They have degenerated. The nerves, the neurons have degenerated. So there are a lot of functions which are not available anymore. They cannot carry out certain functions, right? So it causes loss of ability to reason. So sometimes the person cannot even think and reason, okay, logically, and unable to take care of themselves. The patient becomes confused because they cannot reason. They sometimes can find it difficult to understand things. They become forgetful. You tell them already, and then the next minute they will ask you again. Okay, so be patient with old people. It's not because they just want to be chongheya, not because they really want to ask, because they seriously they cannot remember. They cannot process the information, okay? And they become disoriented, confused, disoriented. Okay, sometimes they do not know where they are. They might be in their home, it's in a familiar place, but to them, it is like a foreign place, like they've never been to this place before. Okay, everything that they see, it looks different from what it actually is. So, okay, so I don't be surprised. I've experienced with people in my family who have had a little bit of this kind of Alzheimer's. So they are in the living room and they'll say, this is the toilet. Okay, so it's difficult to explain, because we don't think like that. We don't have this, so we think they're just hallucinating. Okay, it's not their fault. Okay, continual deterioration of the brain. If the brain continues to deteriorate, you can see it shrinks, right? This one, deterioration, this is deterioration definitely, right? It will cause the person or the patient to lose the ability to read, to write, to eat, to walk, and even talk. Sometimes they cannot even recognize their own family members. Okay, sometimes you bring the grandchildren, they say, who is this? Cannot remember who is this grandchildren. They don't recognize the familiar face. So healthy brain looks like this, all right, with a healthy neuron. And the unhealthy one, you can see the tissue of the brain, the neurons of the brain tissue is shrunk. And then you have a lot of dying neurons, okay, inside the brain. Okay, right, next one. Parkinson's disease. I'm sure you've heard of this, also very prevalent among old people. And it's mostly characterized by the first signs initially we associate Parkinson's disease is with shaking, tremors. Okay, they will be shaking part of your hand or the leg, whatever, will be shaking. So it's caused by the shrinkage of the nervous system. So the nervous system shrinks and it causes tremors. Tremors is shaking, okay, in the limbs, in the foot, the face, okay, all these. That's why you will find that all people who have Parkinson's disease is uncontrollable shaking in certain parts of the body, okay, and it causes their posture. They have difficulty in maintaining body posture and also body balance. So when they walk, sometimes they drag their feet along. It's like what they call shuffling. They shuffle, small steps. They'll be taking small steps. Okay, tremors, postural instability, unable to maintain a good posture, and rigidity. That means very rigid, very keras, and mask-like face. The face is a bit expressionless. So it's like you're wearing a mask there. It means no smiling, no nothing, like no expression, an emotionless kind of face. Okay, it's mask-like face. And scientists have found out that why do people suffer from Parkinson's disease? It's usually because it's attributed to the lack of dopamine. Remember, dopamine is one of the neurotransmitters that, across the synapse. So if the body is unable to produce dopamine, all right, that person may have this Parkinson's disease symptoms of Parkinson's disease. You have tremors, there's slowness. Okay, so it's dopamine that is associated with Parkinson's disease. All right, okay, next one, yeah. Let's carry on with the next one. Right. So, you remember, do you know this important and famous person? Okay. Does anyone know? I want to know. Do you know? You're science students. You should know who this famous person is. Well, I can't see anybody here. So I assume you are there, but maybe you do not want to make yourself known. Okay, it's all right. I'm sure some of you will know, but you dare not, right? You're scared to be wrong. This is Stephen Hawking. Stephen Hawking is a very, very famous person. He is regarded as one of the smartest people that ever lived, okay, because he postulated the Big Bang Theory, how the universe started. And he also has this theory of relativity. Yes, E equals to mc squared. Yes, Stephen Hawking, Ridwin, yes, correct, Stephen Hawking. So he passed away in 2018, in March. It's about 5 years ago. All right. So other than him being famous, being very smart, you notice that he always goes along everywhere in his wheelchair and his motorized wheelchair, and he can't speak. He has a brilliant brain, genius, but he cannot speak. Okay, he has what we call a serious condition called amyotrophic lateral sclerosis, or ALS for short. Okay, now this is an inborn kind of thing. He didn't contract it. It's not congenital. It is not you can contract from anybody. So it's a congenital disease, and he started to have experienced this kind of muscle problems when he was in about, I think, 21 years old. That time he was still studying in Oxford University. Okay, then later on it became worse, and he was not able to walk. He had to be in a wheelchair. Okay, so this is a disease caused by deterioration. That means it's becoming worse. Deteriorate means becoming worse. And death of motor neurons. So the motor neurons are slowly dying. And these are the ones that produces movement, because they send impulse to the effector. So when you have a normal nerve cell, you are able to send this impulse to your muscle, and your muscle can contract. So you can have your reaction and also all this movement. But if you have sclerosis, ALS, okay, you have sclerosis in the myelin sheath as well. So the impulse are not able to be passed on to the effector. So he cannot move, right? Even though his brain can function, the brain cannot send message, or rather it cannot reach the relevant parts of the body to produce response. Okay, so dead nerve cells, so it causes muscle. At first, it's weakening. He found that he was not able to balance himself. Okay, in the that time was early 20s. Okay, he was starting to show signs of it. Then it became worse until he could not even stand. He was bedridden. Okay, so this is also known. This disease is also known as Lou Gehrig's disease. Okay, if you do see this word Lou Gehrig's disease, it is also ALS. Why they call it Lou Gehrig's disease? Because after there was one famous baseball player, American baseball player, who had this disease also. He was very famous because of a very good baseball player. But when he got this disease, everybody got to know about ALS. So his name was associated with ALS because he was so famous and he got this disease. All right, so everybody got, from that moment, everybody knew about ALS because this famous person got ALS. So it's known as Lou Gehrig's disease. Okay, there's no cure for it, unfortunately. There's no cure. It can only go worse because you cannot repair the sclerosis. Right. Next one, ADHD. I'm sure you've heard of this, right? Very, very common in young children. Not to say young children, children of our ages. When a lot of them, when they're young age, they are very hyperactive. Okay, we call it associated with hyperactivity. So it causes someone to be hyperactive. They cannot concentrate. They cannot sit still. They become impulsive. Impulsive means they do things very quick, or they want to, before the teacher finish talking, they want to ask question. Okay, and also they do things without thinking long. Okay, tak berfikir panjang. Impulsive means they do things quite quick and fast without really thinking through the effect. What happens if I do this? What happens? Okay, what happens in the future if I do this and that? They just do it, right? Impulsive, and also becomes easily bored. Okay, so these are the symptoms or features of people who have ADHD. So first one is unable to focus and difficulty to follow instructions. They cannot sit still. They have to be walking around, especially some children now, babies, they're starting to walk already, start climbing all over the place like monkey. Okay, and sometimes they are very careless. They drop things. Okay, sangat cuai, talk too much, bercakap terlalu banyak, and they might do certain activities in the inappropriate time. Okay, at night they might be people all sleeping, and then they'll be starting to play. Right, difficult to follow. To wait for their turn. Okay, very restless, and they always like to interrupt people when people are talking. All right, they're impulsive. They ask questions before the person has enough time to even finish giving instructions. Okay, so these are symptoms of ADHD, attention deficit hyperactivity disorder. Usually occurs in children. Okay, all right, next one. Okay, let's look at autism. Okay, autism, very quiet. All right, students who are autistic. The type of disease that's related to the development of the nerves in the brain, so a problem with the development of the nerves. So you see some children, they like to play on their own. They don't like to socialize. Okay, you give them a toy, they can play for hours. And sometimes they don't even look at you when you talk to them. When you ask a question, they hear you, but they do not want to interact with you. Okay, this causes an individual to experience problems in communicating. They do not know how to communicate. They are in their own world, like you might say, in your own world, dunia sendiri. All right, they play oneself, they're happy just playing by themselves, and they don't like to talk to people. They don't like to even interact. They won't even say hi. You have to say hi to them first, and they might not even answer you. Okay, so signs of autism: issues with communication. They don't respond. You call also, they won't answer. Trouble interpreting what others feel. They don't even know when you're feeling sad or happy. They cannot even sense. They cannot sense what your feeling is. And then sometimes they have repetitive movements. They will do the same thing again and again and again. Prefers to be alone. Sensitive to loud noises. They don't like loud sound. Okay, they get irritated, and they don't like to look at you, avoiding eye contact. An eccentric way of moving. Sometimes their movement is a bit exaggerated. But don't look down on them. Many of these autistic children, they are very smart. They are very, very smart. There are some people who are autistic, we will call them savants. You give them a certain day in the year or in the entire whatever, say it's 15th of February 1962. They can tell you it is Friday, or they can tell you it's Monday. You give a date, all right, your birth date, they can tell you what day it is. And sometimes they can do extreme fast calculations with mathematics. With times, don't know how many square root of don't know what number, they can even do it faster than a calculator. Okay, so some of them are gifted, but they happen to be autistic. Okay, so it's their brains functions differently. Okay, next one, cerebral palsy, or call it brain paralysis. Okay, you see some children, they need to move with the help of a wheelchair. Okay, they are very young, but you can see that they are strapped to certain parts of the body because their neurons or the nerve system, they have a problem with that. They are not able to walk properly. Okay, so this is caused by brain damage either before or after birth. Okay, so it's either it's happened when the baby is still in the mother's womb, or it can happen after birth. Okay, I have an ex-student who had a cerebral palsy. It's because of she had meningitis. She had a high fever, and after that she developed convulsions and all that, and after that she had cerebral palsy. Okay, so it's very unfortunate, but she was very smart. She's very smart. She's still alive. Okay, she's very smart, and she scored flying colors for SPM. Okay, so usually occurs in children between 3 to 5 years, but it can become later due to, let's say, some kind of a fever, okay, or some kind of an infection of the brain, infection. Okay, and then causes failure in muscle function and inability of the motor neurons to function properly. So whenever your motor neurons are unable to function to the flow. So you can see this sleep disorders, behavior disorders. Okay, this is not so. They don't remember all this is all right. Okay, unable to walk, unable to talk. Sometimes serious cases. Okay, so next one, epilepsy. All right, so you may see some people rolling on the floor like that, shaking with saliva coming out their mouth, frothing in the mouth, and so on. You get scared, right? People call it sawan babi and BM. Sawan babi is epilepsy. So what happens is, why is the person doing that? These are abnormal activity in the brain function. So as you know, there are a lot of impulses in the brain. So it's producing abnormal signals. Okay, the brain is hyperactive, maybe it's producing the wrong signals, so it causes your body to go into convulsion like this. Okay, a person with epileptic attack may become unconscious. The person can be unconscious. The person most of the time don't even know that he has undergone this. Okay, unless you videotape it and show the person, oh, that you were like that just now. They will not become conscious. They don't even know that they did this. Right? And experience muscle spasm, that means convulsion, shaking. Right? So this is what happens because of the disturbed electrical rhythms in the central nervous system in the brain. Okay, some kind, just like something triggered, and the nerves, the impulse were all running haywire, so it causes your body to contract uncontrollably. Okay, and then what you can do is you just make sure the person does not hurt himself or herself. Okay, make sure he does not thrash out and hurt himself, and don't bite his own tongue. Right, then what you can do is, if the person becomes unconscious, you can put in the coma position and so on. Right. Okay, now let's go to the last part. Now, what is the effect of drug and alcohol abuse on human coordination and response? If the person is taking drugs or alcohol, right, how does it affect the coordination and also the response of the body? Now, first of all, let's look at the difference between medicine and drug. What's the difference? Why we use the two words medicine and drug? Medicine will seem like it's a good thing, right? Medicine is a good thing because we use medicine to treat diseases, make the person become better. And then when you see the word drug, when you hear the word drug, okay, oh, it's all negative. Drug means you're bad, right? And the person takes drug, so the person is a drug addict, right? Drug has a negative connotation. Medicine has a positive connotation. Actually, they are referring to the same thing. Whatever medicine you have, whatever chemical it is, it can be a medicine, it can be a drug, depending on how you use it. If you use it to cure a medical condition, then you will call it a medicine. But if you were to take this chemical for your own pleasure, all right, to feel high, all right, for the wrong reason, then it's considered a drug. All right, okay. So many types of drugs. So we can use the drug for interchangeably here. Drug is also a medicine. If it's used for medical purposes, of course, it's a good thing. We call it medicine. Okay, what are the drugs that are used for medical purposes? Example, marijuana. Marijuana, okay? You can hear a lot of youngsters in America, right? They will try out this marijuana. It can be used in hospitals, right, in the medical field to reduce nausea. Nausea is the feeling of wanting to vomit, okay, for cancer patients after undergoing chemotherapy. So they are injected with certain chemicals to kill the cancer cells in the body. So after that, the side effect of that, they may feel that they want to vomit. So they may be given marijuana. And another one, morphine. Morphine is processed from the poppy flower, right? It's used as a painkiller. So patients who are undergoing, let's say, terminal diseases, for example, no cure already, going to die already, okay, like cancer, 4th stage cancer. So doctors will give, on compassion sake, give morphine so that the person will not be so suffering, will not be in so much pain. Right? Okay, there's nothing else we can do for them, right? Unfortunately. So it's just to reduce the pain. We can use morphine. Okay, so drug abuse, when you say drug abuse, means we're using it for other purposes than medical. Means we're not using it to treat diseases. Then we call it drug abuse. Okay, like those drug addicts, they're using it not to treat medical condition. They eat it, they take it because they want to feel high, they want to feel like they have no troubles in the world, they want to feel happy and all that. That is drug abuse. So they can cause serious side effects and also can be fatal. That means can cause death. Okay, let's look at the effects of drug abuse. It can cause addiction, of course, right? You take too much of it, your body builds up a certain resistance, a certain barrier. So after a while, you find taking the same dosage will not have the effect. You got to take more, a higher dosage to feel the high. And then again, it carries on. Higher and higher and higher dosage until you get an overdose. That's it. You die. You die. I'm sure a lot of these artists you've heard, right? They are found dead in the bathroom, in the bathtub. They found dead in a hotel room and all that. Most of it is because of addiction to the drug that they're using. Because they want to, they are too addicted to the drug. And sometimes they overdose on it. All right. So the addiction that causes withdrawal symptoms, sometimes when you do not take it, let's say you're trying to go off the drug, you want to stop the drug, right? You do not want to take it. I want to stop being a drug addict, let's say. So you want to stop taking it, you may suffer what we call withdrawal symptoms. These are symptoms like called shivering, sweating, and vomiting. It's because your body all the while is being fed with this chemical. And suddenly you don't give that chemical, your body goes haywire, cannot function. So you have all these withdrawal symptoms like cold shakes, you know, the shivering, chills, sweating, breaking out in cold sweat. You might even have fever, mood swings, very unhappy, very angry, anxiety, bone pain, vomiting, insomnia, cannot sleep, even diarrhea. All these are withdrawal symptoms because your body does not get the normal dose of that chemical. Your body cannot function already. Okay? So you may get all these things, very headaches, all right, you get fever, you might even get chills and sweating and so on. Okay, so let's look at the last part, yeah? The effects of drugs and alcohol on the human nervous system. So this one you got to remember. This kind of drugs is divided into 4 groups actually. But the textbook adds in another one, alcohol. Actually, alcohol can be considered as a sedative, the second group. So first group, let's look at stimulant. Stimulant drugs are drugs that can make you feel high, make you feel activated, make you feel active and don't feel sleepy. It increases the activity of the central nervous system. You see the word increases? So you don't feel sleepy, right? You feel you can last the whole night. So excessive use of this can cause temporary euphoria. Euphoria means happiness. Then after, when the drug effect goes off, you may get depression. So it's like immediately very high, and then after, when the drug wears off, then you feel sad as well. So stimulants are very commonly used by youngsters because they want ecstasy and all that, and they feel they can shake, they can dance the whole night through. And in the college students and all that, they want to finish their assignment, they don't want to sleep, they're short of time, they want to do the assignment, they don't have time to sleep. So they take all these drugs so they can feel that they don't need to sleep. Okay, it feels your body, your mind becomes very alert. Okay, the other one on the extreme end, these are called depressants. These are called sedative drugs. The drugs that can calm you down, the drugs that make you go to sleep. Okay, so it delays the transmission of nerve impulses. It delays it so that your impulse becomes slower. That means you will not be so active. It calms the mind, and this is usually given to patients who are unable to sleep. Mind is too active. They think a lot of things. Maybe a lot of problems at home. Maybe so they keep on thinking until they cannot sleep. So they have to go to see a doctor. The doctor maybe prescribe some kind of antidepressant. Sort of like what they call not the antidepressant. Sort of barbiturates to calm down the mind so that brain activity is not so active, so they can sleep. Okay, it's a delays. Next one, hallucinogenic. Okay, this is hallucinogen. Hallucinogen are drugs that can make you feel high, that can make you see things that are not there, make you hear things that are not there. We call it hallucinate. Hallucinate, we call it what do you call it in the end? I can't remember the word. It's like you see things that are not there. You hear sounds, so it's very scary. So it also relieves you from the pain and anxiety. Okay, so these drug addicts, sometimes they do funny things. They will climb on top of the train there, on the car there, shouting and screaming and all that. They are hallucinating. Okay, and sometimes they will do certain crime. They will commit certain crime. They kill another person. They stab another person, and then during the trial, they'll say, "I hear sound. Okay, I hear voices in my head telling him that this person is a Satan. Okay, it's devil. So I'm supposed to kill that person. Right, that kind of thing, right? Because the person is hallucinating. Okay, narcotic drugs. These are drugs that numbs your nervous system. It delays the normal function of the brain. So this one can be painkiller. Okay, it blocks the sensation of pain. All right, narcotic drugs like cocaine. Cocaine is under narcotics. All right, and one more. Right now, alcohol. Alcohol actually by right should be sedative. It also delays the transfer of nerve impulses. You can see it's very similar to this group here. All right, so that's why when people are drunk, right, when they drink driving, you call it, why are they prone to accidents? Because the transfer of impulses will be delayed, slower. So when you see the danger coming, right, you are not able to react fast enough. Your reaction is slowed down. Therefore, you cannot avoid the accident because you can't swerve your car fast enough. Okay, you see a dog run across the street. Okay, you want to avoid the car, the dog. All right, sometimes you hit the dog instead. All right, and then you have an accident. So it disrupts your coordination and thinking. Now, before I end, there's one question that I would like to explain. Yeah, one of the questions they ask you, explain why. Okay, this drug called painkillers. How painkillers are able to stop pain. Okay, so the correct answer to say is, now most of you, if you do not know this knowledge, you will say, oh, painkiller kill pain now, right? But what is the what they call the function of it? How does it work to kill pain? Okay, when you have painkillers like morphine, what they do is this painkiller, this chemical morphine, they block the neurotransmitters. You remember your neurotransmitter? They are supposed, these are the chemicals in the synapse, right? They are released into the synapse to sort of like trigger the transmission, the trigger the postsynaptic neuron to produce impulse. So when you don't have the neurotransmitters, your impulse cannot be transmitted. So you cannot have the sensation of pain because it also relies on the neurotransmitter. So what happens when you have a painkiller? It blocks the release of neurotransmitters in the synapse. That's how you answer this question. Okay, how do painkillers work? Okay, so I've come to the end of today's lesson. I hope that you have learned what you should learn. It's be useful to you. So my next lesson will be on 12.6, which is the endocrine system. A little bit complicated, but you need to learn this, right? It's also part of your coordination system. Okay, all right. So thank you very much for watching, and I hope to see you next week, right, for endocrine system. Okay, Ritwin, thank you very much. Okay, so everyone, bye-bye. Have a good weekend, and I hope you enjoy your time in school, yeah? The school has just started. Okay, bye-bye. See ya. Thank you.